Ever wondered how we went from thinking the Earth was the center of everything to sending rovers to Mars? It wasn't an overnight change. It was a revolution, but not one fought with swords and cannons. It was a revolution of the mind, a seismic shift in how humanity understood the universe and our place in it. This was the scientific revolution. For over 1,000 years, the ancient wisdom of thinkers like Aristotle and Ptolemy, along with the doctrines of the Church, provided the definitive answers about the cosmos. Their geocentric model, placing the Earth at the very heart of creation, was elegant, comforting, and seemingly unshakable. The sun, the moon, the planets, and the stars all spun around us in perfect celestial spheres. It was a tidy human-centric universe. But as the Renaissance sparked a renewed curiosity in the world, some people started looking up at the sky and asking, is that really what's happening? The stage was set for some of the most daring and brilliant minds in history to challenge everything. Our story begins in the 16th century with a Polish astronomer and clergyman, Nicolaus Copernicus. He spent years meticulously observing the heavens, and the more he looked, the more the old Ptolemaic system seemed clunky and overly complicated. To make the math work for an Earth-centered universe, astronomers had to add epicycles, which were like wheels spinning on other wheels. It was messy. Copernicus proposed a radical, almost heretical, new idea. What if the sun was at the center and the Earth was just another planet orbiting it? This was the heliocentric theory. He was so worried about the backlash from the established academic and religious authorities that he waited until he was on his deathbed in 1543 to publish his groundbreaking work on the revolutions of the heavenly spheres. The book didn't immediately cause an uproar, but it planted a seed of doubt that would soon grow into a towering tree of new knowledge. The next major player to enter the scene was an Italian astronomer, physicist, and engineer named Galileo Galilei. If Copernicus planted the seed, Galileo watered it and made it impossible to ignore. Around 1609, Galileo heard about a new invention, the telescope. He didn't invent it, but he dramatically improved it and did something revolutionary. He pointed it at the sky. What he saw shattered the old worldview. He saw that the moon wasn't a perfect, smooth sphere. It was covered in mountains and craters just like Earth. He discovered 4 moons orbiting Jupiter, proving that not everything in the heavens revolved around our planet. He observed the phases of Venus, which could only be explained if Venus was orbiting the sun, not the Earth. Galileo's discoveries provided powerful observational evidence for Copernicus's heliocentric model. He published his findings in a little book called The Starry Messenger, and it became an instant sensation. But not everyone was thrilled. Galileo's work directly contradicted the long-held teachings of the Church. He was eventually tried by the Inquisition, found vehemently suspect of heresy, and forced to recant his views. He spent the rest of his life under house arrest, but it was too late. The truth was out there. As Galileo supposedly muttered after his trial, and yet it moves. The Earth was no longer the stationary center of the universe. It was a planet in motion. While Galileo was looking at the very large, others were developing a new way to look at everything. This was the birth of the scientific method. Thinkers like Francis Bacon in England championed a new approach to knowledge. He argued that instead of just accepting ancient texts, we should go out, observe the world, perform experiments, and gather data. This is called inductive reasoning, starting with specific observations and building up to general principles. On the other side of the English Channel, the French philosopher René Descartes championed deductive reasoning, starting with fundamental principles and using logic to arrive at specific conclusions. His famous declaration, "I think, therefore I am," became a foundational statement of rationalism. Together, these two approaches, Bacon's empiricism and Descartes' rationalism, were fused into a powerful new tool, the scientific method. It's a systematic process. You observe something, you form a hypothesis to explain it, you design an experiment to test that hypothesis. You analyze the results, and you draw a conclusion. If your results don't support your hypothesis, you refine it or discard it and start again. This methodical, evidence-based approach to understanding the world became the gold standard for scientific inquiry. It was a repeatable, verifiable way to acquire knowledge, and it allowed scientists across Europe to build upon each other's work, and build they did. The momentum was unstoppable. The final, crowning achievement of the scientific revolution came from a man who is arguably the greatest scientific mind who ever lived, Sir Isaac Newton. Born the same year Galileo died, it's as if the torch of discovery was passed directly to him. Newton was a genius of incredible scope, making breakthroughs in optics, mathematics, and physics. He developed calculus, a new mathematical language to describe motion and change. His masterpiece, published in 1687, was the Principia Mathematica. In it, Newton laid out his 3 laws of motion. First, an object in motion stays in motion unless acted on by an outside force. Second, force equals mass times acceleration. And third, for every action, there is an equal and opposite reaction. These laws described how things moved, not just on Earth, but everywhere. But his most profound discovery was the law of universal gravitation. The legend says an apple fell on his head, making him wonder why it fell down and not sideways or up. He realized that the same force that pulled the apple to the ground was the very same force that kept the moon in orbit around the Earth and the Earth in orbit around the sun. It was a single universal law that governed the entire cosmos. With Newton, the universe was no longer a mysterious divine realm. It was a grand, intricate machine, operating according to precise, predictable, and knowable mathematical laws. The old celestial spheres were gone, replaced by the invisible force of gravity acting across the vast emptiness of space. The impact of the scientific revolution cannot be overstated. It fundamentally changed humanity's relationship with the universe. We were no longer the center of creation, but we gained something far more valuable: the power to understand it. This new way of thinking didn't just stay in the labs of astronomers and physicists. It spilled over into every aspect of life, leading directly to the Enlightenment, where philosophers applied reason and the scientific method to questions of government, society, and human rights. It paved the way for the Industrial Revolution, giving us the technological power to reshape our world. From the medicine you take to the device you're watching this on, it all has roots in this incredible period of discovery. The scientific revolution taught us to question authority, to trust observation, and to believe that the universe in all its complexity is ultimately understandable. And that spirit of inquiry, that relentless quest for knowledge, continues to drive us forward today. Thanks so much for joining me on this journey through the cosmos and the mind. If you enjoyed learning about how our modern world came to be sure to hit that like button and subscribe for more deep dives into history's biggest ideas. Let me know in the comments which figure from the scientific revolution inspires you the most. See you next time.